Okay, let's go to y delta transformation, y delta or delta to y transformation. Okay, some resistors are combined neither in series nor parallel. So y delta transformation is for resistance that are not connected neither in series nor parallel. For example, R2, R3 and R4 not connected in series and parallel. Not in series and not in parallel. R4, 5 and 6 not connected in series and also not connected in parallel. Okay, so we can solve the equivalent resistance for R2, R3, R4 by transform this to y delta or delta y. So for R2, 3, 4, this is delta connection. So we convert it to y. This is delta, so we convert to y. Y or star. Okay, same goes for R4, 5, 6. This is delta connection, so we transform it to y, or we call it as star. Okay, so this is delta connection. Okay, okay, this is RB, this is RC, this is RA. Okay, this is point A. Point A is here. This is A. Okay, so this is B. Okay, so B, at B we have C and A. We have C and A. And then B and A connected together at C. Okay. This is, so if we withdraw this, CB, okay, this is CB, this is A. Okay, so this is Y, okay, or we call it as star. R1, R2, and R3 here. Okay, why we convert Y to delta or delta to Y? To simplify the circuit analysis. This conversion did not take anything out of the circuit or put in anything new. Okay, this is the formula to convert delta to Y. So the original circuit is delta. We have R, A, B, and C. This is delta. Okay, you want to convert this to Y inside R1, R2, and R3. Okay, this is the original. Original is R, A, B, and C. Okay, we convert it to, the original is delta. We convert it to Y. Okay, so R, A, B, C can be R1, 2, 3, R, X, Y, Z. Okay, please do not memorize the notation of R1, R2, R3, R, A, B, and C. Please observe the location. Okay, so let's, we want to find R1, R1 here. So the formula is, the upper side is RB times RC, meaning that the right side and the left side of the R1. Okay, multiplication of the right side and the left side of R1 divided with RA plus BRC, ABC. Okay, all the summation of delta resistance. Okay, same goes for R2. R2 is equal to RC multiplied with RA. Okay, divide with the summation of all R at delta. R3 is A times B. Okay, A times B, the right side and the left side of R3, divided with the summation of RA, B, and C. Okay, this is the formula. How to convert Y to delta? This is the formula. Okay, Y is, this is the original circuit. This is Y. Okay, this is Y. So we want to convert it to delta. Delta is at the outer side. So R1, we want to find RA. RA here. RA is equal to R1, R2. Where's our R2? R1, R2. And then plus R2, R3 plus R3, R1. The multiplication of the summation of R1, R2 plus R2, R3 plus R3, R1. Okay. So the upper side of this division is the same for B and C. Okay, divided with R1. Okay, divided with R1. R1 is the resistance that is opposite with RA. Same goes for RB. RB, okay. The lower side is R2. R2 is the resistance that connected that located opposite with RB. RC, RC here, okay. R3 here. R3 is the resistance that opposite with RC. Any question up to here? Any question? Any question?
No, doctor.
No? Okay. So let's continue. Okay, so this is the formula. Delta to star, star to delta. Again, do not memorize. RB must be here, RA must be here. This is RC. This is must be R1. No, just you can put R1 here, R2 here, R3 here, up to you. Okay, or you may put this. This is RX. This is RY, RZ. Okay, up to you. But please memorize the location, or do not memorize. Just use the formula. Because usually the formula are given in exam, or for online exam you can open your notes and find the formula. This is an example, convert delta network to Y network. Okay, this is very basic and you will get this answer. Convert delta to Y, the original. Okay, this one. Convert the Y network to delta. This is Y. Okay, and then you have to convert it to delta. Okay, let's go to this example. We have this circuit. So we found, okay, how to, okay, the question is obtain the equivalent resistance RAB. How to find RAB or R total of this circuit. Okay, usually we solve, we start with the right side, okay, of the circuit. This is power supply. This is the right side of the circuit. So how to simplify? At this side, we cannot simplify without convert it to Y delta or delta Y, because 10 and 20 is not connected in series. 10 and 30 here is not connected in parallel. 20 and 30 not connected in parallel. Okay. Same goes for this. This 15 and 12.5 is not connected in series, not connected in parallel. 5 and 20 not connected in parallel. Okay. As a summary, all the resistances in this circuit has no connection of series and parallel. Okay. So let's start. Okay. You can solve any part of this circuit. Okay. Either you want to solve this delta connection or the lower side of this. Okay. 5, 15, and 20. Or you may want to solve this side. 10, 20, and 30. This is delta. Okay. Or you may want to solve 10, 5, and 20. This is Y or star connection. Or you may also convert this star connection to delta. Okay. Up to you. Usually, once you transform any parts in this circuit, you can further solve for RAB. Okay. let's say we transform this delta connection, okay, to Y connection, the highlighted area, okay, here. So actually this is delta connection, okay. A here, this is A, and then at A we have 12.5, this is 12.5. So better you convert or you redraw the circuit so that you can see the form of delta, okay. So 12.5, we have C node here, and then we have 5, this is 5, and then at the end of 5 is N node, and then we have 10, and the other node is A here. Okay. So the next step is to draw a Y connection inside the delta. Okay. And then you name the R inside the delta as R1, R2, R3, or RA, RB, RC, or RS, RZ, up to you. Okay. The formula is the formula is here. Okay, so now let's find the R here. Okay, how? 12.5 times 10 divided with the summation of all R. 12.5 plus 15, so we get 27.5. Okay. Okay, and we get this. 4.545, we get this and this by using the formula. Can you try it now and update with me? Either you get the answer or not. Okay. Can you try it now? Please, someone. Sivaswaran. Sivaswaran, can you get the answer? Have you get the answer? Calculating, okay. Nabila Atika, please find for 2.273 here. 2.273. Nabila Atika, do it now.
Okay, doctor.
Okay. And the other one is 1.81. Someone please, Nodiana. Get.
Okay, doctor. Sekejap.
Okay. Get the answer.
Doktor,
Yeah.
yang 2.273 tu dapat 12,
Dap,
uh,
uh,
12.5.
to please write here.
Oh, right. Okay.
Sivaswaran, get the answer. 2.273. Okay, get the answer. Okay, Nabila Atika, Sivaswaran and Nodiana. Okay, good. Sivaswaran. Sivaswaran. Doctor, carry on first. I send in chat in a while. Okay, and then calculate current. How to calculate current? Google. Calculate current. I equals to. Okay, I equal to 12.45. Okay, how to calculate? We go to next calculation. Okay, this is the same circuit, but now we try to convert this Y connection to delta connection. This is Y. Okay, so you may redraw so that you can have better view or better understanding. Okay, so this is 12.5. This is 15. And this is 5. Now we convert it to delta. Okay. Okay. Sorry, forgot to draw the R. Imagine that this is R. Okay, so RA is equal to 3. How to get this R? RB parallel with 10 is equal to 10 is here. This is N. This is A. This is B. Okay. Okay, now please get the R here, here and here. So how to convert Y to delta? This is Y to delta. This is Y to delta. Please try, class. Try. Okay, so how to get the RA is equal to, okay, summation of R1 2. So summation of 12.5 times 5 plus 5 times 15 plus 15 times 12.5 divided with R1. So let's say we find here divided with 15. Okay, 15. 15 is RB. Divided with 15 RB. Okay, so meaning that this is RB. From this calculation, now I put the notation of RB, RC, and RA. RA 5. So this is RA, and of course this is RC. Okay. So now class, can you get the answer? Fazli, can you get RA is equal to 65? Fazli?
Yes,
No,
Doctor.
okay, Safiras, get RB. Yasin, please get RC. RC equal to this. Dapat, Zafran. Zafran got all the answer. All R, A, B, and C, right? Okay, make sure you redraw the circuit. So that you know where is the connection of series and parallel. Okay, so this is RB. This is RC. This is R. Okay. Okay, now after we get the resistance in delta connection, okay, you redraw and then, okay, actually we have a connection here. Okay, after A we have, and then we have connection here. Okay, and then please redraw the remaining circuit and solve. Okay, now RB parallel with 10 here. RB parallel with 10, we get 6.842. Okay, so that and this is RA. Please redraw. This is RB parallel with 10. It is 6.842 here. And then this RC parallel with this R. Okay, RC parallel with 20. We have 20 here, and we get this. Okay, so we have like this, and then we have This is 30. 30 here. Okay. So the next is um, to add this and this. So 6.842 plus 11, and then make it parallel with 30, and then parallel with 30. And we get the R total. Any question?
No.
No, eh? Okay, and then how to get the current? How to get the current? I is equal to V over R. The V is 120 divided with R total is 9.63, and we should get R total. I total. I total is equal to 12.458. Aiman. Aiman dapat? Current. Aiman. Aiman dapat current? Nur Aiman, are you with me?
Yes, Doctor.
Did you get current equal to 12 point this?
Yes.
Okay, good. Okay, next. Okay, I think you can further solve for tutorial to number okay, number 26 is delta connection. Okay, number 26. Later you can solve, you can try number 26. Okay, this is delta connection. Okay, this is Y connection or star connection. Okay. Yes. Okay, so you may how to solve for V here. You may transform 15, 12, and 10 to Y to delta connection. Okay. Or you may transform this 10, 12, and 20 to Y connection. Okay. Let's say we convert this 10, 12, and 20 to Y connection, and let's say we name it as RA here, RB, and RC here. Okay, so RA is equal to 12 times 10 divided with the summation of all the R in delta connection. Okay, here, and we get 2.85. This is 2.85. And then B is 4.76 and C is 5.71. And then please redraw. Okay. Okay, now you can delete the connection of delta. And then redraw. We have 30 here, 15, 35. And then RA here, RB, and RC. Now we know that 15 is series with RA, 30 series with RB. Okay. So 15 series with A is this, and then 15 series with A is parallel with 30 plus B, right? Okay, 30 plus B. So 15 plus A. What is RA? RA is 2.85 parallel with 30 plus B. B is 4.76. Okay, make it parallel and you get 11.79 and then redraw. This is 11.79 and then connected with RC. Okay, now we have we know that we can solve V by using voltage divider principle or current divider principle. Okay, using current divider principle. So by using current divider principle, we find the current flows through 35 ohm. Okay, using current divider principle, we find the current flows through 35 ohm. How? By current divider principle. But firstly, you have to find the current source because in current divider principle, we have to find the current that's supplied to the parallel circuit. So I total is the current that's supplied to this parallel branch. Okay, so I total is equal to V total over R total. So of course, you have to find the R total. R total is 11.79 plus RC. RC is equal to 5.71. Okay. And then must be parallel with 35. And then plus with 16. Okay. Plus with 16. Okay. And then this is the R total. And then how to find the I total? V total divided with R total. And we have 3.614. This is I total that flows from the source to here and then divide to two branches. Okay, so how to find the I that flows through 35? 11.79 plus C. C is 5.71. So 5.71 plus 11.79, you get what? Berapa? 71 7 okay. So 17.5. Okay, the summation of 11.79 and C is 17.5. Okay, so 17.5 divided with the summation of 17.5 plus 35 multiply with the current source. Current source is 3.614. So we get 1.205. This is the current that flows through 35. And then how to get the V drop across 35? V is equal to IR. I times 35. And then we get 42.18. Okay. Or you can also solve this by using voltage divider principle. Okay, but you have to you have to solve for this this parallel circuit. But I think this is the best way, okay, to find the current flows through 35, and then by using Ohm's law, you can find the V here. Any question? Any question? Can you understand this question number 26? This is one alternative. Okay, you can find V by using any approach. Okay, up to you. As long as the approach is correct and you get the answer. Any question? if you can understand this star delta delta star transformation, we can proceed to nodal analysis. Okay, this is another example. It convert this star to delta. Okay, this is the solution. Convert star to delta. So we have 13 here, and then we have 24 and 30. Okay, we have 24 and 30. Delta to star. This is another. Okay, so this calculation convert this star to delta. Okay, this is another solution. Okay, another solution. Another solution. This is method 2. Okay. So it convert delta to star. Okay. This is conversion of y to delta. Okay. So um, so this is star. Our delta is here. Okay, our data is here. So RA is 50. Where is RA? This is RA. RB is opposite with this. RC here. Okay, so RA is equal to 200 plus 220 20 multiplied with 50 and then plus 50 multiplied with 10 divided with 50. Okay, you may redraw this circle. Okay, maybe you want to see the y or the real y or delta. Okay. Okay, this is the R. Sorry, this is the star, and then where is the delta? The star is here. Okay. Calculate and then please redraw. Okay, redraw. Delta. Okay, so we have delta. Okay. Okay, now this is RA. This is RB. And this is RC. Okay. What is this? 24. This is 13. 30 here. Okay. So now we know that 24 is parallel with RA, okay? RA parallel with 24, we get 14 here. Okay, and then 30 parallel with RC. RC parallel with 30, we get 25.5 here. And then we have RB here. Okay. So now we know that this, okay, and then please solve for RAB plus we are 13 here, and R total is equal to 40. Okay, so meaning that it doesn't mean you convert y to delta or delta to y, you will get the same answer. Okay, this is star to delta, or you may want to convert this part. This is star to delta. Up to you. Any question? Okay, at the end we get the same R total 40, 40 here, the same. Any question? Okay. Now we go to nodal analysis. Nodal analysis is an interesting subtopic, but quite challenging. Okay. So what is nodal analysis? Nodal analysis or branch voltage analysis provide a general procedure for analyzing circuits using node voltages as the circuit variable. Okay, so these are the steps. The first is to assign nodes and name it as V1, V2, and so on. The second step is to assign current direction at each node and name the currents. The third step is apply KCL at each node. So number of KCL equation is equal to number of nodes. If we have 3 nodes, V1, V2, and V3, so we must have 3 KCL equation. And then substitute each I that we assign in the second step with Ohm's law. The last step is to solve the resulting simultaneous equation to obtain the unknown node voltages. So in nodal analysis, our target is to find what is V1, what is V2, what is V3, and so on. Okay. The V1, V2, V3, and so on are located at the node. That's why we call it as nodal analysis. Quite difficult, yes. Because in nodal analysis, the important thing, the first step is you have to assign the node. If you cannot assign the important node, then for the rest of your calculation may be wrong. Okay. So the first step is the most important step. Okay. If you assign many nodes, so you will have many KCL, many equation. Okay, because if you assign 2 nodes, meaning that you will have 2 equation. If you find that it has 4 nodes, then you will have 4 equation. To get 4 unknown voltages, V1, V2, V3, and V4. So the most important step is to find the nodes. Okay. Let's look at this circuit. The most important node is only 2, here and here, and we name it as V1 and V2. Okay, this is also the node, but this is the reference node where this is the ground, connected at ground, where V here is equal to 0. Okay, we may ignore this node, but we should know that voltage here is equal to 0. Okay. This is the original circuit. Okay, the original circuit. The question maybe find V1 and V2. Okay, no question here, but the question is find V1 and V2. Okay, let's say the question give you V1 here and V2 here, and you no need to find what is V1 or V2. Or the question ask you to find the voltage at node 1 and node 2. Okay, node 1 and node 2. So now you name it as V1 and V2. Okay. Okay, you should name it as V1 and V2. V1 and V2. Okay. So the first step is to find the node V. So we have only two nodes here. Any question? Why we only have two nodes? Okay. We have only two nodes, V1 and V2. Okay, the next step is to what is the next step? Assign the current direction at each node and name the current. Okay. Okay. So now let's okay, let's find the let's assign the current. Up to you how to assign the direction of current. Up to you. Okay. So this one 1 amp. So of course current enter the node. Okay. So now I highly encourage you to always assign the current to flow through the ground, meaning that current flows out from this node here. Okay, how about this? Up to you. You may make it leave the node or you may make it enter the node, but please be consistent. Now I put the current I2 to flows out from the node, and then it must flow through 6 ohm and will enter V2. Okay, please do not make the direction of I2 and I here different. Okay, because current must be in one direction. Okay, and then how about this node? This is enter the node. Please make this current flows through the ground. Okay, how about this? We have 4 amp. 4 amp is like this direction, so for sure make it follow the 4 amp. If you want to make it current here is inversely with 4 amp, yes, but you can, but current here will be minus 4 amp. Okay, any question? No.
No.
Okay, study hard, Zafran.
Alright.
Okay. Okay, now the next step is what? The next step is to apply KCL at each node. Okay, since we put the direction of current, so now we write the KCL. What KCL state? Current enter the node equal to current leaving the node. Okay, or current leaving the node equal to current enter the node, up to you. Okay, so we have two nodes here, meaning that we have two KCL equation. Okay, so this is at node 1, at node V1. Okay, uh, current enter the node is 1, isn't it? 1 equal to I1 plus I2, or I1 plus I2 equal to 1. Okay, and then this KCL equation at node 2. What is current enter the node? I2 is equal to 4 plus I3. Okay, so here I2 equal to I3 plus I4, right? It is equal to this. So please rearrange so that the round number, apa nombor pula round number?
Nombor
The-
Ya
bulat,
betul.
bulat je.
Ah?
Bulat je.
Nombor bulat je.
Ada
Whole
international.
number.
Round number
Full.
Apa je lah. Okay. Please rearrange so that the unknown uh, um, at the left side of the equation. I1 plus I2 equal to the round number. Okay. 1. And then 4 is equal to I2 minus I3. Okay. And then please substitute all the I with Ohm's law. I1 equal to what? I2 equal to what? I3 equal to what? Ohm's law. What Ohm's law state? Ohm's law. Ohm's law is
V
equal to?
equal to IR.
Okay, this is Ohm's law. Ohm's law. V equal to I R. Okay. So meaning that I equal to V over R. Okay. So substitute with Ohm's law, meaning that I equal to V over R. So I1, where is I1? I1 is the current flows through 2 ohm, meaning that V of 2 ohm divided with 2. V of 2 ohm is equal to V1. Okay. Because V1 is the voltage drop across 2. Same goes for V2. V2 is the voltage drop across 7. Okay. How about V of 6 ohm? V of 6 ohm is equal to V1 minus V2 because current flows from V1 to V2. Okay. If you assign the currents to flow inversely with this I2, so V of 6 is equal to V2 minus V1. Okay. It follows the direction of current. Okay, so I1 is equal to V1. Actually, I1 is equal to V1 minus 0. Okay, 0 volt here. Okay, actually, we have 0 volts here. Actually, I1 is equal to V1 minus 0. Okay, I1 minus 0. Sorry, V1 minus 0. Divided with 2. I2 is equal to V1 minus V2. Okay. Divided with 6. And then we have I3. I3 is equal to V2 minus 0 divided with 7. Okay. Or you may just write V2 divided with 7. This is the original equation. V2 minus 0 divided with 7. Okay, now substitute all the I definition into the KCL equation. Okay, so we have I1. I1 is equal to V1 divided with 2. V1 divided with 2 plus I2. I2 is equal to V1 minus V2 divided with 6 equal to 1. Okay, so this is the first equation. And then you may rearrange to become this, or you just leave it as in fraction. Okay, but make sure you rearrange in terms of V1, V2 equal to the round number. Okay, and then substitute all the I in the second equation. I2. Okay, so this will be the first equation. I2 equal to V1 minus V2 divided with this. Okay. Minus I3 minus I3. I3 is equal to V2 divided with 7. Equal to 4 equal to 4. And then please rearrange to become V1, V2 and equal to round number. Okay. This is 13. Okay. Okay, please simplify. This is 7V1 minus 13V2 equal to 168. Okay. This is 7V1 minus 13 V2 equal to 168. This is the second equation. Okay. And then now, by using calculator, so we have this equation, the first and the second. We have the first and the second equation. Okay. By using your calculator, please try it now. If you forget how to solve the two equation, press mode equation, press 1. How many unknowns? We have 2 unknowns only. Press 2 and then key in the number. A1 is 4 followed by I think B1. B1 is minus 1. This is minus 1 V2. So minus 1. And then C1 is 6. And then A2, right? A2 equal to 7. B2 equal to minus 13. This is C2. C2 is 167. Okay? Try it now. So what did you get? V1 on and V2.
Doktor,
This is the answer, yes?
kalau buat manually maknanya kira-kira by
Also
hand lah.
can. Boleh.
Dapat ada markah ke? Ke tak ada?
Up to your lecturer. Up to me. Yes. You can use calculator or you can manually calculate. Okay. Without calculator. As long as, okay, the mark is here. The first equation, the second equation, and then because you use your calculator, so the next mark is for value of V1 and V2.
So guna calculator lah senang doktor kan doktor kan?
Yeah, of course.
Alright, thank you.
Dia tengok
Okay
muka.
now. Okay now try to get V1 and V2 by using calculator or manual calculation, up to you. It is important to rearrange your equation in terms of V1 followed by V2 and then equal to the round number. If you do not have round number here, please make it equal to 0. Okay. Same goes for another equation. Rearrange in terms of V1, V2 equal to round number. And then solve using calculator. Now, did you get the answer of V1 and V2?
Dapat tu, dapat.
Yes.
Okay. Okay. Good. So, this is the very simple circle. Okay. Okay. Now this is another circuit. The first step is to assign node. Okay, the important node. So we have only 3 nodes here. If you assign 4 nodes, then you will have 4 equations. Okay, please be careful in determining the number of nodes. Okay, so let's name it as V1, V2, and V3. The next step is to assign the arrow of current. Okay, so okay, at V1, please follow the arrow of this 3M. Okay, make it enter the node. And then here, up to you, you may make it and leave the node or enter the node. Same goes for here. You can make it leave the node or enter this node. Okay, but make sure. Let's say I put IX. Okay, okay. Please observe this circuit. We have IX here, so just name it as IX and do not make the IX enter node 1 because it will inversely with this IX, right? Okay, just follow IX. Okay. follow this IS. Follow this IS. So IS leave this node and make sure IS must enter this V2. Okay. How about I1 and other I? Up to you. Okay. Now current, let's make this current leave this node. Okay, and then it will flow through 4 ohm and surely it will enter this node. Okay, do not make it leave this V3 because it will conflict with I1. Okay, so I1 here and this one must be I1 also. Do not put another name I3, IS, IY. Okay, it will give you trouble. Okay, and then settle for V1. How about V2? IX must enter this node. And then this current make it go to reference node or ground. Okay. Let's say I name it as I3. This is, how about this? Up to you. You may leave the node or enter the node, but please be consistent. Okay, let's say this current and leave the node, so must flow through 8 ohm and enter this V3. How about current here? Must be the same name as 2IS. So this is 2IS. Okay, 2IS is current source. It will flows leave the node. Okay, 2IX. This is 2IX. Same. Okay. Okay, what is the next step? To write the KCL equation. This is the circuit, the previous circuit. Okay, now this is the way how to write. Add node 1, add node 1 or add node V1. Okay. What is current enter the node? 3. So 3 equal to I1 plus I3. Okay. This is the second node. At node 2, what is the current enter the node? IX. IX equal to I2 plus I3. And then this is the third node. At node 3. Okay. So what's the current enter the node? I1 plus I2 equal to the current leaving the node 2IX. The next step is to substitute all the current with Ohm's law. Okay. So for this equation, 3 is equal to I1. I1 is equal to the current flows through 4 ohm. Okay, V. So I is equal to V over R. I1 is the currents flow through 4 ohm. Must be divided with 4. Okay, this is V4 ohm. Okay, V of 4 ohm is equal to V1 minus V3. Okay, if you put the direction of current from V3 to V1, it is inversely with I1. So this will be V3 minus V1. Okay, divided with 4 and plus IX. Where is IX? IX here. IS is equal to V of 2 ohm. Okay, divided with 2 ohm. V of 2 ohm is equal to V1 minus V2. Why? Because you put the flow of current from V1 to V2. Okay. Any question up to here? Any question?
Faham.
Bagus.
No.
Okay. And then please rearrange this equation so that it will be V1, a V2, a V3 equal to round number. Okay. So what you have to do is V1 divided with 4 plus V1 divided with 2, you will get this. And then minus V2 divided with 2. This is V2 divided with 2 or equal to minus 0.5 V2. And then you have minus V3 over 4. This is minus V3 over 4. You may leave it in fraction or in the apa ni? Number, okay? Not in fraction. And equal to, huh?
Decimal.
Oh, decimal. Okay. Decimal. Equal to 3, okay? So this is your first equation. Okay? This is your first equation that you will key in your calculator. Add node 2. Okay, this is add node 1. This is add node 2. This is add node 3. Add node 2. Ix is equal to, just take this V1 minus V2 divided with 2. Equal to I2. I2 is equal to here. V2 minus V3 divided with 8. Okay, why? Because I2 flows from V2 to V3. So V2 minus V3 divided with 8 plus I3. I3 is equal to this V2 minus 0 or just V2 divided with 4. Okay, now rearrange. So you will have V1, V2 and V3 in order. Equal to, just put 0 if there is no round number here. Okay, this is our second equation that will be in your calculator. Okay, and note 3, I1. Substitute I1. So we have I1 here. So just take this V1 minus V3 divided with 4 plus I2 like this. V2 minus V3 divided with 8 equal to 2IS. We have 2 in the bracket of IS is this. V1 minus V2 divided with 2. Please rearrange and you will get this. Any question? No? Okay, so now try to key in all the 3 equations in your calculator and make sure you get this answer. Now, did you get the answer? So if you want to solve manually, yes, you can use metric, right? But of course, it is more difficult, more challenging.
Take times.
Yeah. Okay. Get the answer. So it is important to take into account the the sign, okay? So this is minus 0.5 in your calculator. This is minus 0.25 in your calculator. Yasin? Get the answer? Yasin, did you get the answer? Yes. How about others? Muhammad Zafran? Khairi, get the answer?
Tengah kira jap.
Yes.
Yes, Zafran.
Tapi V1, V2 dapat negatif. V3 positif.
Okay, please check your data in your calculator, okay? Make sure A1 is equal to 0.75. A2 is equal to minus 0.5. Same goes for here. This is B1. A2. A2 is equal to minus. Do not leave the sign of minus. Minus here, minus. Put in your calculator. Diana dapat. Okay. Let's try tutorial number 29. Okay, number 29. Okay, how about this question? The question asks you to find V1, V2, and V3. Okay. So in this question, V1 is equal to V2 is equal to V of 4 ohm. V drop across 4 ohm. Okay. How about V drop across 2 ohm? Zafran, what is the V drop across 2 ohm? It is V1 minus V2. Okay. If you put Ix in the opposite direction of this Ix, so V2 is equal to V2 minus V1. Okay. So by
Okay.
referring to this I2 direction, V of 8 ohm is equal to V2 minus V3. How about V of 4 ohm? It is V1 minus V3. Okay. Yeah, it follows your flow of current. Okay, now try number 29. Okay, in this question, it gives you node V1 and V2. Okay, we have only 2 nodes here, meaning that we have how many equations, Khairil?
2.
Only 2 equation, okay? Only 2 KCL equation
Yeah,
at V1 and at V2 to find 2 unknown voltage, V1 and V2 only, okay? So the question is to find V1 and V2 using nodal analysis. V1 is equal to the V drop across 5 ohm. V2 is equal to the V drop across 4 ohm. V of these 2 ohm is equal to the difference of V2 and V3 depends on your flow of current, either V1 minus V2 or V2 minus V1, up to your direction of current. Okay, now try number 29, obtain V1 and V2. So how to solve this? Let's look at the solution here. Okay, you may try yourself. Try it now. Okay, this is my flow of current. Up to you. You may decide your own flow of current, direction of current. Okay, so we only have V1 and V2 here. Okay, how about current here? Make it flow to the ground. Okay, so I1 flows like this. I2 to the ground also. How about current here? Just use this direction, it's amps. Okay, how about current here? Up to you. You may make it like this or opposite to this. Okay. So this will be, so where is I4? Okay, so this is wrong. I4 okay, I4 must no need I4, just use I3. I3 must be enter V2. Okay, so now let's write the KCL equation. So current enter, no current entering, all the currents 6. Okay, I1, I2, I3, I1, I2, I3 equal to 6. Let's do it. Okay, class, try yourself. Try yourself.
On the way, Doctor, on the way.
Okay. Class, have you done?
Yes.
And get the answer. Got the answer.
Of course. Yes. Yes.
Okay, good. How about others? How about others? Siva Swaran? Nabila? Asfa? Siapa jawab
Dapat
tadi?
doktor.
Dapat.
Aspa jawab tadi.
Asfa dapat. How about others?
Ha.
Irfan? Khairil? Who else? Aiman?
Faham.
Khairil? Got the answer?
Still calculate.
Nah, calculate sampai habis. Calculate until you get the answer. Dua puluh. All of you get the answer? All of you got the answer? Okay. Hmm. Okay, now try number 30. Okay, number 30. We have only two nodes here. Okay, at the right side and the left side of 2M. Okay, this point is shared with this point. Okay, I3 share with this point. Okay, so we only have two nodes. Okay, V1 and V2 like this. Okay, like this, V1 and V2 only. Okay, so the direction of current is already given in the question. I1, all the current flows to the ground. Okay, so at node V1, what are the currents enter the node? Only 4 and 2 amps. So 4 plus 2 equal to I1 plus I2. Okay, now this is the first equation. This is the first equation after you substitute all the current with Ohm's law. So I1 is equal to V1 divided with 5. I2 is equal to V1 divided with 10 equal to 6. And then we get V1 is equal to 20. How about V2? Okay, this is V1. V1 is equal to 20 volts, but the question asks you to find I1 through I4, meaning that I1, I2, I3, I4. So I1 is equal to V1 divided with 5. V1 is 20. 20 divided with 5 is equal to 4. And so on. Find for I2. And then the equation at V2 is 5 equal to 2 plus I3 plus I4. Okay. 5 is equal to 2 plus I3 plus I4. And then substitute I3. I3 is equal to V2 over 10. I4 is equal to V2 over 5. Okay. Is this equal to 3? And then we get V2. Then we can find for I3 and I4. Very basic equation. And then number 31. Use nodal analysis to obtain all the nodes voltage in the following circuit. In this circuit, we only have okay, try for number 31. Okay, Shazam, how many nodes here? In your opinion, how many nodes here? Two. Okay, actually, if we refer to the answer, it seems like we have 4 nodes, right? Okay, obtain all the nodes voltage, meaning that we have nodes here, 1, 2 here, 3 here, and 4 here. Okay, that's why we have 4 answers here. So assume that 12 volt is here. So the node voltage, if you put the node here, so V here is equal to the voltage source, 12 volt. And then V here, 2.4 volt is the voltage here. And then 4 volt is the voltage here. It is the voltage of 2 ohm. And then 0 volt is the voltage at the ground. Okay. Actually, okay, if ignore the question here. Ignore the question here. Ignore the answer here. Now I want to ask you, in your opinion, how many nodes in this question? Ignore the question. Ignore the answer. Okay. When you look at this circuit, how many nodes you want to put?
2 boleh?
2.
3.
Hi. 3. Okay, when you have 2 nodes, you will have 2 equations. When you have 3 nodes, means that 3 equation. Zafran, 2.
Yeah.
Okay, where? Where the node? Where are the
Atas bawah.
nodes?
Tengah-tengah.
Okay, here and
Yeah.
0. Okay, so we know that we can ignore the ground, okay, because we know that the ground is 0 volts. Okay,
Oh,
okay,
yeah.
so your answer is approximate to the best answer, meaning that we only have here. Okay, Asfa, you know the answer. Okay, so the most important node is only here. Okay, only here, one node only. So then we will have one equation. Okay, so let's write the equation. Let's write the equation here. So the leave the node. This is leave, and all the current leave the node. So the equation here is 2 plus I1 plus I2. Okay, I1 plus I2 plus 2 equal to 0. What is I1? I1 is equal to V1 minus 12 divided with 4. Okay, what is what is I2? I2 is equal to V1 divided with 6. What is here? Okay, no need to find the current here because we already have the current. It is 2. No need to find other equation. Okay, so if okay just now I mentioned that I1 is equal to V1 minus 12 divided with 4, right? Okay, now how if the voltage source is located at the opposite way, meaning that positive and negative, but positive at the lower side, negative here. So equation here will be V1 minus 12 divided with 4, meaning that V1 plus 12 divided with 4. Okay. Okay. Maybe I should okay, this is tutorial number 31. Okay, tutorial 2 number 31. Okay, we have 4 here, 6. We have current source of 2 amps and then 2. Okay, so this is I1. This is I1. This is I2. Okay, this is 2 amp. Okay, so we only have one node here. Okay, so here is 12 volt. 12 volt here, meaning that this is 12 volts. Okay, because we know that V1 here is equal to V of 6. Okay, so 12 here is equal to 12 here. V of 6 is equal to V1. Okay, so the equation is only I1 plus I2 plus 2 equal to 0. I1 is equal to V1 minus 12. Okay, divided with 4. Plus V2 is equal to V1 divided with 6. Okay, equal to minus 2. Equal to minus 2. Okay, and then rearrange V1. Very simple. You have only one unknown. Okay, and then you will get V1 is equal to what? Okay, V1 is equal to 12. V1 is equal to 2.4, right? Any question? Apa ni? Oh, okay. Okay, V1 is equal to 2.4. V1 is equal to 2.4 volts. Okay, this is mesh. Okay. How about finding this? Okay, this is number 33 is mesh analysis. Okay. How about finding V naught by using nodal analysis? Okay. Try. Number 33. Try it now. Try it now. Okay, how many nodes here? For your opinion, in your opinion, how many nodes here? How many nodes here? How many nodes? How many nodes?
2.
2. Irfan, how many? Yasin said 2. Zahirul Haq 3. Irfan?
2.
Only 2, okay? Where is it? Where is it, Irfan? Irfan?
Tengah-tengah.
Tengah mana? Here and here, okay?
Yeah.
Ah. Okay, so V1 and V2. Okay, so you will have two equation of KCL only. Okay, so now let's put the flow of current. Make it leave the node. Okay, leave the node. Go there. There. This one enter. How about this? How about enter this node? And this one just go to the ground or follow the notation of V naught. V naught is positive here, negative here, meaning that current flow from up to down. Okay, go to the ground. Okay, so now let's write the KCL equation at V1. Okay, now I skip the step of assigning. I skip the step of name the current. Okay, let's say this is I1, I2. I skip that step. Okay, I jump to the substitute all the current with Ohm's law. Okay, at V1, all the currents leave the node. Okay, here current flows from V1 to 40 volts. So V1 minus 40 divided with, okay, now we use nodal here. V1 minus 40 divided with 1 and then plus V1 minus V2 divided with what? Nabila, Atika?
2.
Okay, 2. Lain suara. And then plus 5, right? Okay. May I just make it equal to minus 5. Okay. Any question up to here? No, right? Okay, now please.
Okay.
Okay, now please rearrange V1 plus V1 over 2. Okay. So you will get okay, minus V2 over 2, okay, equal to minus 5 plus 40, equal to 35, right? Okay, this is your first equation. And then at V2, okay, class, you may try yourself. Here is V1 minus V2 divided with 2 plus 5 equal to V2 over 4 and then plus ini masuk, enter this one. Okay, at this note, this V1 minus V2 over 2 plus 5 plus this one, okay, plus how? Now I want to change. I want to make it leave the node. Okay, enter and leave the node. Okay, so here is equal to, this is enter, this one is leave the node V2 over 4. How about this? This one, V2, okay, minus divided with A. Okay, and now please rearrange. Rearrange, please. Minus 7V2 over 8. Okay. And then equal to minus Am I right? Yeah. Am I right, class? 1. Unknowns 2. Deh. C 35. Itu 78. 7, 8. Apa ini? Class, please try to calculate so that we can compare. We can compare our answer. So equal to V2 equal to 20 volts. Yeah, the answer is right. Can you understand?
Yes, yes, understand.
Bagus. Ustaz Asfar. How about others? Can you understand, all of you? Okay. Just now Hairil said that nodal analysis is quite challenging, right? Quite difficult, kan? Okay, so now did you feel nodal analysis is interesting? Quite difficult or quite or very interesting? Okay, number 33. The question asks you to find V naught using mesh analysis. So if the question asks you to use mesh, if the question state the method, so you must use that method. Otherwise, no marks. Okay. So now let's we use nodal to find V naught in this question. So in this question, V naught is equal to our V2. Okay. V2. So you may name this node as V2 or as V naught as well. Okay, any question? Any one of you cannot understand my calculation of number 33? Just ask. If you really understand the concept, then any circuit will be easy. Okay. Any one of you want to ask me about this question? Yes, ni apa? Got the answer, right? Yes, yes ni. You got the answer, okay? Okay, you may challenge yourself. Doktor dapat jawapan. Okay, you may challenge yourself by solve number 32 by using a nodal analysis. Okay, so in your opinion, how many nodes in number 32? How many nodes?
One
Rose?
node.
One node.
Only one node. Good. Very good. Okay, where is it? At the middle, right? Okay. So if you have one node, you will have one equation only. Okay. So this 3 volt you can put here. Make it 1 ohm here. You may redraw. Okay. If you cannot, if you confused with this circuit, you may redraw. So make it 1 ohm and then 3 volt. Put it down. Okay. So here, if you put the current flows to the ground, let's say here is V1. Okay. So here V1 minus 3 divided with Zafran 1. Okay.
1.
Okay. Okay, now let's try. So V naught is equal to what? After you get V1 here, you may use V naught by using what?
Ohm's law.
Ohm's
Like that.
law. If you use
KVI
Ohm's,
tu.
if you use
KVL.
Ohm's, KVL.
Voltage divider.
Yes. Who's that? Irfan. Okay,
Wow.
Irfan. Voltage divider. Okay. Why voltage divider? In voltage divider principle, we need voltage source that supply to that path, right? It is series. Okay, so now in this path, the voltage source is here. V1. Let's say this is V1. So V1 will supply to this path. If you want to find the V0 is equal to 2 divided with 2 plus 3 times V1. V1 is the supply voltage in this case. Okay, so let's try. Now, using nodal analysis, find V0. So you have to apply nodal analysis to find the V1 here and then find V0 by using voltage divider principle. Try it now. Number 32. Okay, let's try it now. The answer is 1.112.
The answer is 1.2, Doctor.
1.2?
Yeah.
Okay, 1.2. Aiman.
Yeah.
Aiman Ahmad.
Yes.
What is your hometown?
Malacca.
Melaka Aiman Ahmad bukan orang Arab ke?
I'm from Yemen.
Sorry?
From Yemen, international.
Yaman. Okay. Which part Yaman?
Taiz.
Sorry?
You know Taiz? North.
No. Oh, okay, no. Okay, Aiman, so you got 1.2.
Yeah.
Okay, how about others?
Sorry, doctor, it's 1.112.
Okay. Okay, I got this. So, how about others? Rosliana, you got the answer? Rosliana? Any question you want to ask me regarding this question or anything about Nodal? Or anything about our lesson today? Or still calculating? Anyone of you cannot understand our lesson today or want to ask something about Nodal before we end our class? Anyone want to ask something?
No, doctor, no.
No. Can I know the schedule of the classes? So, refer to your schedule. Our class is on Monday, 2 until 5, 3 hours, and Thursday, 9 until 1, 4 hours. That's all. Only 2 slots in a week. Today we should end at 5 or 5:30. Okay. If you have textbooks of Sadiku, okay, Matthew and O Sadiku, okay, you may try many question there. It is in chapter 3 if I'm not mistaken. This is Y delta, okay, Y delta, and then do you have this book or e-book? Super Nodal. Okay, there are many questions. Um, we do not cover super node. Okay, this is super node. Super node is a voltage source located between two nodes. Okay, so we did not cover super node. So there are many questions. Okay, this is super node. Super node. We do not cover super node. Mesh. Okay. Okay. Many questions there. You may try it. Okay. Nodal. Okay. This is as in your tutorial. Number 3.4 is same as your tutorial. And then using nodal. Okay. Okay, number 3.7. How many nodes here? Nabila Atika? Asyik Nabila Atika, ya. Anissa, how many nodes in number 3.7? Anissa? How many nodes here? Number 3.7, how many nodes? Soalnya. How many? 1. Anissa said 2. Only 1, Anissa. If you have 2, then you will have 2 equation. Only 1, okay? Or maybe, okay, Anissa, where are the nodes? You said 2, where are the nodes? Anissa can speak or not? You have mic or not?
Tengah-tengah.
At the middle here, and the other one is?
Tepi tu.
This. Okay, all the branch here share one node, okay? This can be joined together. Why? Because there are no resistor at the middle. No resistor here, no resistor here. And then you can connect all these branch together. Okay? How to... Macam mana? Understand or not, Anissa? Understand or not, Anissa?
Yes, yes. Understand.
Okay. Understand, okay. Meaning that we can join all the nodes together. How? Like this. At this point, we have 2 amps, and then we have 10, and then we have 20, then we have this source, okay? Same for this. Buruknya lukis. This one, ground, okay? Macam apa tah? Okay. How about number 3.9? Number 3.9. How many nodes here? Aiman Ahmad.
Yeah, it's only one.
Sorry?
One.
One only. It is here,
Yeah.
right?
Yeah, it's in the middle.
Okay, only one. Okay. How about number 3.10? How many nodes here?
3.
Sorry, Yasin?
You mean?
Who's answer? Aiman. Aiman Ahmad.
Yeah, it's
Okay.
3.
3. Okay. Yes. 3. Rosliana, how about your opinion? How many notes in number 3.10? Rosliana? Rosliana? How many notes here? Are you with me? Rosliana? Rosliana, are you with me? Rosliana dah balik Safiras? How many notes here?
3.
3. Dah masuk asar dia ke solat Okay. Safira, yes, 3. Okay, 3 One here, and one here. Must be 3. Okay. If you put only 2, so not enough. How about number 3.12? How many notes? Orang lain pula. How many notes? Diana? 2. Okay. Wait. 2. Yes, 2. One here and one here. Okay, only 2. One here and one here. Okay, so in this study book, there are many examples you can try, you can challenge yourself. So that if you think that nodal analysis is challenging and confusing, so you can try a lot of example and question in this book. Okay. Okay, how about this? 3.13. This question put 2 notes, but you may try how many notes? 3.13. This question put 2 notes. Yes, Yasin. Just note at V2, okay? If the question did not specify V1 and V2, you just put only one note here at V2, okay? How about this? Number 3.14. 3.14. How many notes here? Yes, 2 notes. Here, one note and another one here. Okay. Okay, I think you can understand better. Right? Okay, number 3.17. How many notes? 2.
3 Doctor, 3.
Okay, 3. Yasin, where are the notes? Okay, you said that we should only have 2 notes. Where are the notes? One here. Another
Yes.
one here. Right.
Yes, one here.
How about this?
Also here one.
Okay. But if you want to make it only 2, yes, you can. But this note, you should make it 60 volt. Okay, 60 volt. So meaning that when you want to find the current of I naught, okay, I naught is equal to 60 minus this node. Okay, divided with 4.
Okay.
Okay, this one only 3 nodes. Okay, this node can join together, become V1. Same goes for this branch, and this branch can join together at V3. Okay, what else? Here V of A is equal to V3 minus 12. What is the voltage of V3 here? Diana? What is the value of V3 here? Diana? Or others want to answer? What is value of V3?
13 volt.
Yes, 13. This is supernode. We did not cover supernode. Okay. What else? Wow, so many nodes here. V1, V2, V3, and V4. If there are more than 3 nodes, then some calculator cannot calculate. Then it will not be in your exam and midterm test. Okay, midterm test is only up to 3 nodes because of the constraint of some calculator. Okay. Some calculator can calculate up to 4, but some calculator cannot. Okay. Okay, what is the voltage drop across 5 ohm? Zafran, what is the V across 5 ohm? Let's say the current flows through to the ground. Okay. So V of 5 ohm is equal to?
V2
Okay.
minus 4 I naught. Bagi 5.
Good. Okay, I think that's all for today. All of you can understand, inshallah, right? Okay. Okay, I think that's all. All of you want to pray? That's all for today. We will have this Thursday. We will learn mesh analysis. On we have another subtopic or chapter. It is diode. Okay, that will be covered next week, or maybe I just upload the video. Why there is echo? Someone speaking, Khairil Naim.
Yes. No.
Okay, I think that's all for today. Thanks for listening to me. Bye-bye.
Thank you, brother. Bye.
Thank you, brother.
Bye-bye. You're welcome.
Thank you, Dad.
Thank you, Doctor.
Okay.